Hello, this is Chemistry Central Science, 11th edition. We're in Chapter 4 on aqueous reactions and solution stoichiometry, and this is the end of the chapter questions number 37 and 39. Classify each of the following substances as a non-electrolyte, a weak electrolyte, or a strong electrolyte in water. Okay, I've included a periodic table. If you were to have acids, an acid is something that can donate a hydrogen or a proton, a hydrogen ion, H+. A base is normally something that can accept a proton. And there is a short list of strong acids and strong bases. Now, strong, if you're thinking of a strong acid, you might be tempted to think, well, this is more potent, or it could burn you more, or it could react faster, or something like that. A strong acid is one that, when you put it in water, breaks down into cations, which are positives, and anions, which are negatives, completely. So if it's a strong acid, it completely breaks apart. If it completely breaks apart, then you've got charges in the water, and those charges can lend electricity, can move through that water. So if you were to break it completely apart and you have just positives and negatives, then you have a strong electrolyte. Okay, so it is a chemical that, if you put it in water, can conduct electricity. That's what strong electrolyte means. Weak electrolyte means that it only weakly conducts electricity, and the reason why is because it doesn't break down perfectly. Imagine that you put in a molecule and it's got red Legos and blue Legos, but they don't break apart 100%. So 90% of the stuff you put in the water would still be compound. It would still be red and blue together. Then you'd have a few reds and a few blues. That's a weak electrolyte. If you put it in the water and it completely breaks apart into reds and blues and completely breaks apart into positives and negatives, that's a strong electrolyte. So the easiest way to do this question is to know what your strong acids and strong bases are. Okay, so let's look first of all at the bases. The bases are hydroxides, OHs, of these guys. Okay, so it starts off, okay, you have lithium, sodium, potassium, rubidium, cesium. So these guys. So 1, 2, 3, 4, 5. And then from cesium go over, you have barium, strontium, calcium, these three. So there are 8 strong bases. So cesium hydroxide, rubidium hydroxide, potassium hydroxide, sodium hydroxide, lithium hydroxide, and then go down to the bottom, barium hydroxide, strontium hydroxide, and calcium hydroxide. Those are your strong bases. If you have those, you have a strong electrolyte. Okay, so let's see. Do we have any of those? I've got this, but this is ethyl alcohol, which has got a hydroxide, but it's not one of these with hydroxide. That means it's weak. If it's not strong, then it's weak. And that's pretty easy. You memorize just a couple things, and then everything else has to be weak. So this is going to be weak. Okay. Also, you will, as you work with this, know that ammonia is a base. Ammonia can grab an H plus and turn into ammonium, NH4 plus. All right, so since this is a base and it's not one of these guys, it must also be weak. All right. The other one is acids. There are 7 acids that are strong, okay? And 5 of them have to do with group 7. So let's look here at group 7. I've got chlorine, bromine, and iodine. If I have HCl, HBr, or HI, those are strong acids. Okay, so hydrochloric acid, hydrobromic acid, hydroiodic acid. Those 3 are strong. Now, if you have oxygen bonded with the chlorine before you put your hydrogen on it, like ClO3 or ClO4, so chlorate, hydrogen chlorate is chloric acid. Perchlorate is perchloric acid. So those are two more. So you have 1, 2, 3, 4, 5 with your oxygen. So that's 5 out of 7. Then you've got 2 to memorize. HNO3 from nitrate, nitric acid, and H2SO4, sulfuric acid. Those are all of your strong acids. Strong acids make strong electrolytes because they completely dissociate in water. They break down into charges. And if you have charges in the water, then you have electricity able to move in that water. Okay, so let's look. H2SO4 is sulfuric. This is sulfurous acid, so it must be weak. Okay, and those are the only ones with H's. So the only acid that I have here is a weak acid, and so weak acid makes a weak electrolyte. So there are 7 strong acids, 8 strong bases. Everything else that's an acid is weak. Everything else that's a base is weak. Okay, and strong acids make strong electrolytes. Strong bases make strong electrolytes. Weak acids and bases make weak electrolytes. Okay, because they don't break down completely, and so there's not enough charges in the water to allow electricity to flow. Right. The other 2 things I have is salts. A salt is made up of something on the left and either something on the right or some kind of a polyatomic ion. So I've got potassium, which is a cation, and chlorate, which is a polyatomic ion, and they will always break apart. So they break apart completely. So any type of a salt where you have something on the left, okay, and something on the right. So sodium chloride is a salt. We call that table salt. But you have hundreds of salts. Anything where you have an ionic bond is called a salt. So these ionic bonds in these 2 cases are from polyatomic ions. You have chlorate, which is -1, so you have potassium chlorate. You have copper and nitrate, so nitrate's -1, so this must be copper 2 nitrate. And so they will break apart. So any salts completely break apart and make strong electrolytes. Okay, if they completely break apart, they're going to be strong. So we have weak, 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 strong, and strong. Okay? All right, great. That's 37. 39, complete and balance the following molecular equations and then write the net ionic equation for each. All right, a net ionic equation is, first of all, remember some things are going to be soluble and some things are not going to be soluble. Let me dig up our swimming pool. All right, the first one I have is hydrobromic acid, and Br is one of my kids, so it's soluble, and also we know it's a strong acid, so it's completely it dissociates. It completely breaks apart. Remember, it was chlorine, bromine, and iodine with hydrogen chloride, hydrogen bromide, hydrogen iodide, called hydrochloric, hydrobromic, hydroiodic acid. So these break apart. These are strong electrolytes. So if they were to come back together, they would just break apart again. And this is calcium and hydroxide. So calcium is on the left. Hydroxide is a polyatomic negative anion. So it's a salt, and it breaks apart. Okay? So soluble simply means breaks apart. If it dissociates, it's soluble. It breaks apart in water. All right? Well, if calcium and hydroxide come back together, they'll just break apart again anyway because they're aqueous. So both of those are aqueous, and aqueous means soluble. They're in water. They're broken apart in water. What if the other 2 partners come back together? Okay? All right, so let's see what we have. Hydrogen with hydroxide. Okay? So we have hydrogen, here's the cation, hydroxide's the anion, and so we would end up with hydrogen hydroxide, HOH. What is that called? That's called water. Okay? That's HOH. And what would be the other one? Would be calcium and bromine. Okay? Well, calcium and bromine is just a salt. You've got one on the left, calcium, one on the right, bromine. So it's a salt, so it's going to break apart, and so this one is aqueous. But this guy, water, is not a salt. It's liquid. So it's actually something. All right, so you're making something. Well, what do you make the something? So in order to do a molecular equation, you need, and this is a net, let's see, and write the net ionic equation. So the molecular equation is what we just wrote down. This is you're making water plus calcium bromide. Okay. The net ionic equation means I'm only interested in the stuff that makes the water. The water is not aqueous. Everything else is aqueous, which means it doesn't really make a compound. It's floating around as ions in the water at the beginning and at the end. But H2O is actually I made something. Well, what do I need to make the something that's not floating around? All right. Well, I need some hydrogen and I need some hydroxide. So before that, I need to find out what is going to be ions at the beginning and end. Well, I'll look here, and I'm going to write down these all as ions. So first of all, it breaks apart as H plus and Br minus, and both of those are aqueous. You would have to write aqueous and aqueous. Then you're going to have calcium. Calcium is 2 plus, and 2 hydroxides. Okay, because you have got that subscript 2. So on the left side, you've got hydrogen ion, bromide anion, calcium ion, and 2 hydroxide polyatomic anions. On the right, okay, I've got H2O, which is a liquid. That's what I'm actually making. And I have calcium 2 plus and bromine 1 minus. What is the same on both sides that I can cancel? Right? I've got a calcium 2 plus and a calcium 2 plus. I've got a Br negative. I've got a Br negative. Those are called spectator ions. They are on both sides as ions. So they don't participate in the reaction. What's the reaction? The reaction is hydrogen, hydroxide coming together to make water. And so you're going to ignore everything that's spectator and simply write down everything that's not. So you're going to see H plus 2OH minus yields H2O liquid. This is called the molecular equation, and this is called the net ionic, this is the molecular equation here. This is the full ionic equation, where it's complete ionic equation, and then the net is everything that wasn't canceled. The net ionic equation is the H plus the two OH's yield water. All right? Let's try it again and see if it makes any more sense yet. Okay? All right, so I've got copper hydroxide. Well, what's going to happen? Copper it's with hydroxide's -1, there's 2 of them, so that must be copper 2 plus 2 hydroxide ions plus, all right, there is perchloric acid, so it's going to donate the H, so that's H plus, all this is aqueous, plus ClO4, -1, that's aqueous as well. All right, so if copper and hydroxide come back together, they just break apart again. If the hydrogen and the chlorate come back together, they're just going to break apart again. Okay, so that's nothing. What if they switch partners? Will they break apart or not? We'll see. Okay, so I'm going to have H from the chlorate, from the perchloric acid, and the OH from that. What is HOH? It's water again. Okay, I made water again. And what was the other one? Copper 2 plus perchlorate, and that's just a salt, because I've got something from the left and I've got a positive and a negative. Okay, any ionic compound is called a salt, and a salt will simply dissolve in the water, completely break apart. All right, so that means on this side I have water, which is a liquid, and I have copper ions and 2 chlorate ions. Okay. Now, I would have to balance this equation. Let's see. So, perchloric is 1. So to balance this, I would have to balance it first. There would be 2 here. Okay, in order to get 2 chlorates and 2 hydrogens, means I'm going to have 2 hydrogens here and 2 chlorates here. Okay, 2 head chlorates there, 1. Okay, so everything is balanced. Now, what cancels? All right, well, what do I have on both sides? I've got copper 2 plus, copper 2 plus, and is that all? Chlorates, I've got 2 chlorates and I've got 2 chlorates. Good, so those are your spectator ions. What's left over? Whatever's left over is going to be what you make your stuff. It's the net, it's what's left over after. Like your net pay is after taxes. So I'm just going to write down everything that's left over. 2OH plus 2H plus. Those are aqueous and aqueous yields. Okay. And then this would be 2 waters. Okay. So this is the molecular equation. This is the complete ionic equation. And this is called the net ionic equation. All right. One last. We almost there. Okay. All right, we have aluminum hydroxide. Hydroxide's -1, so aluminum must be +3. All right, and it is a positive and a negative, so it's a salt, so it just dissolves. So I'm going to end up with Al3 plus 3OH minus. Okay, and then nitric acid, remember, is a strong acid. Nitric was one of the 7 strongs. So I'm going to end up with H plus NO3 minus. So if they come together, they're just going to break apart again. But if you switch partners, you could possibly have something that's insoluble, all right, like a solid or a liquid or a gas. So let's see, the aluminum nitrate, and aluminum is 3, and so nitrate's -1, so there have to be 3 of those, plus hydrogen hydroxide. That's water again. So we're making water again. All right, so that means this on this side is going to be Al3 plus 3 NO3s. Okay, so to balance everything, we have to have 3 NO3, NO3, and 3. So I shouldn't have scratched that out. This is the molecular equation. Okay. Then when everything is broken, this is called the complete ionic equation. Now, and then I need to write this one again, H2O, liquid. All right, so what is your spectators? All right, I've got 3 NO3s, 3 NO3s, 1 Al, 1 Al. What's left over? Hydrogen plus hydroxide yields water. Okay, so that is my net. So I have 3 OH, -1, plus 3H plus 1 yields 3 H2O, liquid. And that is my net ionic equation. Okay, hopefully 3 examples gives you a little bit more like, okay, I'm getting this. And how do you know if it's soluble or not? That's what the swimming pool is. Okay, so you know if it's salt, it's soluble. If it's something along the side, like lead, chloride, or whatever, any of these exceptions, then that would be a solid, and that's what you would make. And then your net ionic equation would be what we made. All right? Okay, good enough for today.